Hello everyone and welcome. In this lecture we look at the difference between images as float versus integers and color maps, jet versus gray. In the previous lecture we saw that we could represent images by one of the two methods, either by using 0 to 255 or 0 to 1, right? The lower end is black and the upper end is white in both representations. In this lecture we'll see how we can use a couple of functions to represent images either as floats or integers. Okay, the first thing we need to do is import those methods. We also need to import data from scikit-image. So from skimage, import data. I have already done that in the previous lecture, so this is just to remind you. And next, let's import the two methods. The methods are known as image as float and image as ubyte. Let me write it down. Image underscore as underscore float. And the second method is known as image as ubyte. So let's import them from skimage. Import image as float and then image as ubyte. Let's look at the Chelsea image. So we load the Chelsea image and then save it in a variable called cat. So data.chelsea, and once we have our Chelsea image, the next thing we need to do is, by calling this image as float and image as ubyte methods, we can represent Chelsea as a float image or as an integer image. So to do that, we simply call the methods. So let's first call image as float method and then pass our cat image object, right? And let's save this in a variable called cat underscore float. Okay. And now if we call our cat underscore float, we see it's a three-dimensional array. Okay. And similarly, we can represent our cat image as an integer by calling this image as ubyte method and save this in a variable called, let's save it in cat ubyte. So that will be image as ubyte, and then we'll pass cat. Now that we have these two image types, we can call the data type method to find out what kind of data it is. So we'll call the data type method. We'll see that it's a float, whereas if we call our cat ubyte object and then call the data type on it, we'll see that it's an integer 8. And similarly, we can call the maximum and minimum methods on our cat float object. So that minimum, it will be 0, whereas if we call the max method on our cat float, it will be 1, right? In this case it's 0.905, and we saw that in the previous lecture it goes from 0 to 1 if we use the float type, whereas if we use the other type, it goes from 0 to 255. So if we call the minimum and maximum method on our ubyte object, we'll see that the minimum value is 0 and the maximum value will be 0.9 times 255, right? Around 230 something, I believe. Let's do that. So cat underscore ubyte dot maximum and run it. We have 231. So those are the two representations of images, and you'll see that the float method is used mostly, And the scikit image library uses this method, and the float method is more common. And again, when you use the float method, values will range from 0 to 1, whereas with the other method, the ubyte integer 8 method, uinteger 8 method, values range from 0 to 255. Next, let's look at our color maps, jet versus gray. Before we see that, let's look at another dataset from our scikit image. Okay, and the dataset we look at is known as the camera dataset. So data.camera, and let's save this in a variable called image. And this dataset contains a person holding a camera. Let me show you what it looks like. So we'll use matplotlib's imshow method and simply pass our image object. So if you haven't imported matplotlib, please do so. So plt.imshow, and then we'll pass the image. So if I run this, you'll see that this is the image of the person. This is the camera image that scikit image has. So here you see that the image is not so clear. That's because the default color map for our image is called a jet color map. So this is the jet color map. So if we do another plot, plt.imshow, and then we pass our image object, and then if we set the color map to jet, we see that it's the same color, the same picture, whereas if we use a color map of gray, we'll get a different result. Let me show you that. So plt.imshow, and then we have our image, and then let's set the color map to be equal to gray. Now if we run this, we have a better or nicer picture, right? So the default color map for the scikit image is jet, and you see that jet is not a good choice for a default. You see here that a gray color map does a much better job. Okay, to further demonstrate this, what we'll do is we'll zoom into this person's face and draw a picture of this area. Okay, and we'll compare the jet color map with the gray color map around the face area. So what we'll do is, since images are arrays, we'll slice them by this location. For instance, for our x-axis, the face lies between, let's say, 100 and 200, around that area, whereas for the y-axis, the coordinates will be maybe between 85 and 200. Okay, let's do that. So we have our image, and for the x-axis, let's say between 100 and 200. For our y, let's say let's also try between 100 and 200. We can later adjust this values. Okay, and we'll save this in a variable called, let's say, face underscore image. And now let's use the imshow method to see this face image. So plt.imshow, and we'll simply pass the face image and run it. Okay, we haven't quite captured the face. Let's change the values. Let me copy that, paste it here. So I'll change this values to maybe from 70 to, let's reduce this to 180, and for this values, let's make it 180, to 300. And let's call the imshow method again, plt.imshow, and then pass face image. Okay, looks much better now, right? Now we can see the face and the camera, some of the camera at least. So this is the default color map, right? If we also pass a color map of jet, you'll get the same result. Now let's use a gray color map. So plt.imshow face image for color map, let's pass gray. Now if we run this, you see here the gray one is much better. It's much clearer than the jet color map. You see here, there we can see some kind of contour lines around the face here by when we use the jet color map, whereas it's much clearer with the gray color map. So the default color map, which is jet, is not a great choice for our imshow method. One thing we can do to avoid this default color map of jet is set the default color map to be gray. For that we can use a method known as rc_params. So matplotlib has this method that will set or help us set the default color map to gray. Let's do that. So in order to do that, we'll call the rc_params method, rc_params, and then we simply pass, we'll index and pass our image color map to be gray. So we can simply say our image dot color map and set it to be equal to gray. So this will set the default color map to gray. Okay, run it. Now if we call plt.imshow and then pass image, we'll see that the image is gray. So now the default color map is set to gray. We no longer need to pass color map, the color map attribute, and set it to be equal to gray. We have also seen another attribute known as interpolation, and the default value for our interpolation attribute is bicubic. And so far we have seen an interpolation value of nearest. We can also use the same method to set our default interpolation to be nearest. Okay, so if I copy this, paste it here, and pass the interpolation attribute, interpolation, and use nearest for instance, this is what it looks like versus a bicubic interpolation. So setting the default interpolation to nearest will give us a nice and smooth interpolation. Okay, and we can use the same rc_params method to set the image interpolation to nearest. Let's do that also. So plt.rc_params, and then we'll first index our image interpolation, so image.interpolation, and then we'll simply set it to nearest. Great. Just to recap what we saw in this lecture, we looked at the two image types, float versus ubyte or uint8, and we saw the maximum and minimum values for those. And we also explored the camera dataset from scikit image, and we saw that the default color map of jet is not a good choice, and we were able to set or change the default color map to gray by using the rc_params method. And we did the same thing for interpolation and set